This is part 7 of my robotics experiment utilizing the Raspberry Pi computer and the BBC Basic Programming Language. I made major modifications during the past several months in various aspects of this experiment. That includes power supply, Raspberry Pi enclosure and mounting, infrared sensors, relay board, and lastly, the BBC Basic program. Further development will take place within this year, especially in the aspect of movement and sensing. And they are as follows. The DC motor will be replaced by stepper motor, while the motor controller will be replaced with a more efficient design to achieve full control and precise movement for movement programming. Additional sensors will be added to improve autonomous sensing. And if time permits, I will replace the old RPI with the RPI B Plus or A Plus that I have now in my collection. As you can see here, the RPI B Plus has more GPIO in the 40-pin connector header. More GPIOs means more sensors that can be included or installed on this robot experiment. As you can see here, I am now utilizing the lithium-ion batteries as power source. This power source is made up of 6 power banks connected in series and in parallel. Each power bank is rated at 3200 milliampere hour or 3.2 ampere hours at 4.12 volts without load. We can assume that the battery is actually at 3.7 volts under load condition. I made some minor modification on each power bank so that I can still use the built-in charging circuit. Be reminded that charging the lithium-ion is not the same as charging a lead-acid type batteries. The built-in charging circuit on this power bank has full charge cut-off circuit which prevent overcharging that will lead to early deterioration of lithium-ion battery. Although the batteries are connected in series parallel combination, it is wired to produce 12 volts, 6400 milliampere hours. Each charging circuit is disconnected from batteries. This is the original terminal which have been cut off from the circuit board to the cell. To charge using the ordinary standard smartphone charger rated 5 volts 1 ampere, you need to put a jumper between these 2 points. It has to be done individually. This is the standard USB mini USB terminal for charging. This is the output, which will no longer be used. Compared to previous parts of this experiment, the Raspberry Pi is enclosed in a modified transparent plastic and mounted on the side portion of this robot. Now it is mounted on top and housed in a modified anti-static container together with two IR sensors, circuit boards, and a relay board. The infrared sensors and relay board installed on this robot are no longer the prototype that I originally designed from scratch, but the one I'm now selling on my website as kits. For those interested, visit www.kits-gadgets.com. This is the infrared relay board, infrared circuit board. There are two inside this box, and the relay board with 8 relays on it, and the Raspberry Pi Red B. The RPI and the IR sensor board from overheating are incorporated a blower fan that can be switched on manually. Temperature sensor will be included in the feature to activate the fan automatically. As you might notice here, a heat sink and a transistor-like device is exposed. Actually, this is a 5 volts regulator for RPI, originally mounted at the bottom of this robot. It provides power source for RPI from common 12 volts battery source. The infrared transmitter are not connected by wire. You can see the infrared light here visible on the camera. This wire connects to the infrared circuit board here inside the box. Both sensors are mounted on a single modified housing made of common rubber eraser. This is a eraser. This I modified. Note that the housing is engraved so that the back reflection or backstabbing from infrared LED will not reach the IR receiver module, thus preventing the IR circuit from working properly. Noticeable also, in front of this robot are the holes. These are windows for another IR sensor with longer range for collision avoidance, working in tandem with the ultrasonic sensor. The BBC Basic was also updated to include feedback of the status of the sensors. However, the GPIO table does not include yet all the GPIO ports. These are the status of some of the GPIO sensors. Before I end this part 7 of my video, I would like to reveal my original plan for this experiment to my audience. Although from the beginning of this experiment, it was shown entitled as Raspberry Pi Robotics Vacuum Cleaner. The idea and concept of the project is for utilization of Raspberry Pi for robotics car or self-driving car and quadcopter or drones as many called it. Now that more GPIOs are available in the latest RPI, I think it becomes more possible to utilize this tiny computer for such purpose. So that's it for now. Until my next part 8 issue of this experiment.